Hey everyone, welcome back to our podcast. It's your host Akshat, and today's episode is going to be an exciting deep dive into the world of prompt engineering, Gen AI, and LLMs. We have got a fantastic guest lined up for you today. We have Karthik with us. Let's get started and hear from Karthik himself. So, Karthik, let's start with your professional journey and what got you into AI.
Yeah, hi Akshat, hi guys. So currently, I have got around 6+ years of experience. So initially, I started as a Python developer, backend developer.
Okay.
Later, from the beginning itself, like I was very much fascinated by AI. Also, from my college days, I was fascinated by mathematics, especially calculus and
Mm-hmm.
statistics and probability.
Mm-hmm.
That is one of the main reason. Like I was very much interested in mathematics. That's one of the main reason why I dived into this AI. And also, like AI as a technology, also it was very interesting. And my output was during 2017. So at
Mm-hmm.
that time, AI was on the boom. Okay, so it was not like currently how the AI is. It was not like it, but at that time, it was an emerging technology. Okay, so when I was
Yeah.
when I got output from my college and when I joined the company, so most of the companies, so
Mm-hmm.
there were lot of talk regarding AI. But like in most of the companies at that time, maybe you can take as big giants. So big giants. So they currently they were doing some research on that field, but it was not up to the client level. Okay, so there
Yeah.
was no ready-made solution to the client, but there was some research going on in that field. And also one more reason, why it was not that much feasible at that point is, as you know, like computation was the main constraint in training the models. So at that time, we didn't had very bigger GPUs,
Okay.
right? So that was the main reason. And also, currently, if you take current industry or current ongoing trends in training the large language models or any generative model as such, so we
Mm-hmm.
have come up with various memory optimized techniques, right?
Okay.
So there are a lot of like, for example, if I want to give you LoRa is one of the technique, and QLoRa is there, and ReLoRa is there. So these are all some of the memory efficient way of training the large language models. Okay, so these techniques were not there at that time. That is one of the reason, and also, like as I told you, there was a it used to be very costly. Training process used to be costly at that time. Okay, and there was no much advancement in GPU and GPU architecture. So these are all some of the reasons, like why AI was still emerging during 2017.
Yeah.
Okay, so that made me to come to this field. Initially, like for 1 year, I worked as a Python backend developer, and parallelly, I was learning AI as well. I was learning. Initially, I started from mathematics fundamentals.
Mm-hmm.
Okay, so for freshers like who are listening to this podcast, maybe it can be a great help to them. So they can start from mathematic fundamentals. For example, probability and statistics, it's very important. And yeah, probability and statistics, if you take, it's there is a lot of things, right?
Okay.
So starting from mean, standard deviation, and up to higher concepts like SVD, singular value decomposition, principal component analysis. There are a lot of things are there. They can start from step by step. I mean to say, starting from basic statistics
Mm-hmm.
to advanced statistics. And also, if you take probability, probability is also a very huge, right? So there are a lot of probability concepts we will use in machine learning, right? So this mathematics and AI, it goes hand in hand. See, there can be all these mathematical concepts has been implemented by the packages and modules, right? But like if you want to work in research field and all, understanding the fundamentals is very important, because if you are designing a cost function and all,
Yeah.
that cost function, if you are designing, like you need to have a very fundamental understanding of mathematics.
Yeah.
So what I recommend is, take your time, it will it's not like you will learn that in 3 months or 6 months. It might take huge time as well, depending on their learning speed. So take your own time. But my concern is like, my suggestion is like, concentrate on mathematical fundamentals, right? So I was talking about probability and statistics. So there are a lot of very good resource available in YouTube, or it can be in Google as well. So I, as far as I remember, I referred a lot of different lectures. I mean to say, how I was learning is, I used to gather ideas from the different people. For example, you take the example of PCA, principal component analysis. So I used to look into the many different videos. It can be video lecture series, or it can be something on Google. And later I used to understand like how this person might think about this PCA concept, and how another person may think about this PCA concept, right? So it helps to deep dive into the topic, and later you will get your own intuition on it, right? So you will have your own idea on the topic.
Yeah.
And also, like, I recommend to learn on, so just don't learn on very theoretical. First, theory is very important. Theory behind the topic is very important. Then
Mhm.
you must apply it to practical or real world scenarios. So
Yeah.
you must learn mathematics in such a way, right? So, and like, coming back to the follow up, like, first you start with statistics and probability. So once you finish that, you can go for calculus. So calculus, to be calculus, like, definitely we will use this differentiation for the cost function, or in order to get to the optimal point in the cost function, we use this differentiation. So but what I recommend is, like, you can go through the differential equations as well. So that will also really help, like, if you are working on like memory optimization, and training the model with less memory and all this in-depth knowledge in calculus really helps a lot. And also, like, if you take in machine learning, we have got regularization concept, right? So for example, if we have got a plot of data, and if you're trying to fit a line into it, this is a linear regression. And sometimes what happens is, the model will overfit to that training data. That is really not required. We must generalize the data. That's where this regularization concept comes into the picture. So what I recommend is, like, there are a lot of tutorials as well, like Andrew NG series. These are all really very good series. Okay, so, but before starting this high level or advanced or any ML topics, starting from this linear regression to decision trees, and later starting the deep neural network series, start with fundamentals of mathematics, understand, like, understand these basic concepts in mathematics. Okay, and they later you can go into the this machine learning or actual deep learning things. So yeah, so start with probability, statistics, and calculus, and later, like, go to the machine learning fundamentals. There are around 9 to 10 algorithms are there, starting from linear regression, random forest, k-means clustering. Yeah, and you can start with deep neural networks, right? So what is artificial neural networks, and convolutional CNNs, and sequence based modeling, RNNs, and later you can deep dive into the advanced NLP, like transformer based architecture, right? So attention based models. So, and later you can go into the LLMs. Currently, what the trend is going on. So yeah, so this is what the pathway you can follow.
Okay. So can you also tell us any specific AI or LLM project that you are currently involved in or you are excited about?
Yes. So here currently in our industry, right? So I have touched into the various domains. Like, for example, like, we are doing a lot of projects in life sciences, right? So for example, there can be drug testing in the field of drug testing space, where generative AI can be applied, right? So it can make, for example, see, if you take this life sciences, especially drug testing, so it's a
Mhm.
very time consuming, and it requires like very deep depth SME or domain knowledge.
Mm-hmm.
Only like pharmacists or advanced chemists can do this drug testing or combine different chemicals and come up with the drug compositions and all. So here we can use GenAI, right? We can use GenAI and we can accelerate that time. So that's where, like, that's one of the field where I am working on.
Mm-hmm.
And also like I have been working on in automotive field as well,
Mm-hmm.
where we can use intelligent systems in the cars, right? So you can ask any questions to the car, where you have incorporated that LLM intelligence in the car, and it can answer any of your queries.
Okay.
So yeah, along with that, if you use some gestures and all, so you can build really cool applications.
Okay. And like people talk about, prompt engineering and LLM fine tuning.
Yeah.
How do you describe a balance between those, and like what is best for what scenarios?
Okay, that's really a very good question. See, first of all, like prompt engineering, LLM fine tuning, and before fine tuning, like there can be LLM pre-training.
Yeah.
To be very specific, we will call it as continual pre-training. So there are two types of pre-training, right? So I will
Mm.
start with LLM pre-training. So later we can go to the prompt or
Yeah.
inferencing using
Yeah.
the pre-trained model. So basically, if you take any LLM, so it will be pre-trained on enormous amount of data. So later, like you can do continual pre-training using the existing model weights, already learned model weights, right?
Mm-hmm.
So that technique is called like we will be freezing the model weights. Like the model will be trained on enormous amount of data. You will freeze that weights, and you will domain specific pre-training you will be doing on your own domain.
Okay.
So that can be like continual pre-training.
Okay.
Okay, so for example, if you take right now, like there are very famous 7 billion models are open source models are available, like Llama to 7B and Mistral 7 billion is there.
Mm-hmm.
And recently, Hugging Face released a new model called Zephyr 7B beta,
Yeah.
and
Yeah.
alpha version was also there. So these are all the some of the popular LLM models in the
Mhm.
7 billion parameter space. Right. So for these, all these models comes under the category called casual language modeling, where like basic underlying training technique is like it will be trained in such a way, such a way that it will be predicting the next token. So and you will prepare your training data in such a way, like you will shift. For example, for example, if you take any training sample, like my name is Karthik, right?
Mhm.
So this will be converted to the tokens, because any machine learning models, it understand numbers.
Mhm.
And how you will create that token? So you will build a vocabulary,
Okay.
right? So you will build a vocabulary for that model, right? So for example, if you take chat GPT 3.5 or GPT-4, it has got vocab size of 32K.
Mhm.
That means the model can process 32K tokens at a time.
Okay.
And if you take Llama to 7B, since this is a 7 billion model, so vocabulary size is small, like 4K. To be very specific, it's 4032. Okay,
Okay.
so it can process like 4K tokens at a time. I mean to say, like, if the vocabulary size or if the context window, okay, here, like, okay, sorry, I just got just rechange the name. So that 4K is the context window size for the Llama to 7B, and
Mhm.
32K is the context window size for the GPT. Right. So basically, it will process that much number of tokens at a time. So that's the intuition of like what this context window is. So like while during pre-training and all, you need to take care of these things, like what is the context window, and also like there is a very good code. So whatever the data you will give for the training, right? So
Mhm.
quality of data is very important during training or fine tuning or pre-training. So the thing is, you take very small data, right? So you take very small data, but you maintain the quality of it. So then LLM definitely performs really very well on the quality data. So this is something regarding pre-training, right? So pre-training, like a model, casual language models, like usually all the LLMs you take, those are all comes under the category of casual language models.
Yeah.
So casual language models are trained on next token prediction. So
Okay.
this is something regarding pre-training, and there is one more technique called fine-tuning. And like for most of the companies use fine tuning rather going for because pre-training is a very time consuming process, and also it's a very costly process. So I can give the example, like for example, if you want to pre-train GPT-2, right? GPT-2
Yeah.
base.
Yeah.
So that's like first, like that is second version of model released from the OpenAI.
Mm-hmm.
So that is like 124 million model. So if you are pre-training that, it
Mhm.
almost consumes around 6 GB of GPU
Yeah.
just by taking batch size of 8. So not batch size of 8 is very small.
Yeah.
So I'm just giving a figure, like what the pre-training looks like, and I told it's a very costly process, right? So this is why like most of the companies don't go for pre-training. So rather they will either do prompt engineering or they will go for fine tuning. So fine tuning is where, like for example, in fine tuning there are two types of fine tuning. One is instruction based fine tuning, as well as one more is like fine tuning you will be doing for Q&A task. So one of the drawback of fine tuning is you need to prepare the data. So that can be in the form of question and answer, or it can be in the form of instruction based Q&As, right? And like, yeah, you can, there is one more like prompt engineering, as you told you. So prompt engineering is where you will be okay. So like I would like to talk about little bit about the format of the prompt
Yeah.
to come up with the best answers for your task.
Yeah.
So basically how you must format your prompt is like, so you must be having very general template at the beginning. I mean to say, there you must mention like what is the task you are doing,
Mm-hmm.
right? So for example, if you are composing, if you are trying to do any for if you are trying to predict any reaction by
Mm-hmm.
combining two chemicals, you can give that general description in the general template or general prompt. Then what you must do is you must then second section is like task specific prompt.
Okay.
Okay, and it is also called as in context prompt.
Mm-hmm.
So basically in prompt engineering also there are two types of technique. One is like zero shot prompts, where
Yeah.
you will just mention the topic, and you will give the question and model will give the answer,
Yeah.
right? So this is the just zero shot prompt. And there is one more type of prompt called in context learning prompt, or it's called few shot prompt,
Yeah.
right? So where what we will do is you will give some certain examples,
Mm-hmm.
and you will give like what is the ground truth label for those examples,
Yeah.
and you will ask the question. So model will understand from those few short examples, and it will answer, right? So most effective way is like you must go for in context learning, so then the accuracy of the model will be good. Yeah, so like your base question was like when we should go for prompt engineering
Yeah.
or when we should go for fine tuning.
Yeah.
See, one thing is like in prompt engineering also the model can hallucinate.
Okay.
So for example, if you take yeah, but if you want to have very specific or model which must be trained strictly on domain, then we
Mm-hmm.
must go for either fine tuning or we
Okay.
must go for pre-training.
Okay.
So that's based on the hallucination. There are different metrics to evaluate like how the model is hallucinating and all.
Yeah.
So it's based on your need. So uh, if you're okay with just prompt engineering, and if you are satisfied with the answer what it is generating, so that's fine. You can just go for prompt engineering. But it's hallucinating more in prompt engineering, then you must think of this fine tuning or pre-training methods.
Okay. Like since you mentioned about like matrices to evaluate hallucinations,
Hmm.
what are the general like evaluation frameworks like one can use to evaluate generated output text from LLMs?
Yeah. So basically, if you want to evaluate LLM outputs, right? So there are two ways to evaluate. So there are one is like you try to check the semantic meaning of the generated output from the LLM.
Okay.
Okay. So you will use another LLM
Mm-hmm.
to evaluate like current LLM which you want to use for inference.
Okay.
So that is like you will be evaluating semantic meaning of generated output.
Okay.
And there are different metrics in metrics for evaluation, like perplexity is there,
Yeah.
and recall is there, F1 is there.
Mm-hmm. Mm-hmm.
So yeah, it's purely based on like whether if you want to capture semantic meaning, or if you want to like for example, if you're doing summary task, then you will be using this perplexity on these different matrices.
Yeah.
Yeah. And there
And
are different packages as well. Like you just call those packages, you install and call those packages, and they will give the evaluation metrics. Like, uh,
okay.
yeah.
And like once in production, like all these matrices, like they need some sort of ground truth
Hmm.
to benchmark.
Yeah.
So, like, what are the various matrices one should keep in mind while in production? Like, how do you track performance of your AI feature in production?
Yeah. Okay. So, so see, one way of evaluating LLM output is like get it verified by the SMS.
Okay.
So, for example, if you are using the LLMs for the any advanced chemistry,
Okay.
so you must get the output verified by the SMS,
Mm-hmm.
and later you can come up with certain statistical methods.
Okay.
For example, you will verify it on just a sample of test output. Then you can come up with certain statistical methods like T statistic method and all
Mm-hmm.
to check it on the population, whether how it will behaves on the population.
Okay.
Yeah, so these are all some of the techniques. But better is like get it verified by the SMS
Okay.
domain experts.
Okay. And like this is, a very fast moving landscape. Like
Hmm.
everything is changing so fast. So how do you ensure you are up to date with the ever evolving field?
Yeah, so okay, here like before answering this question, right, I would like to highlight the evolution of this NLP. Okay, I wanted to talk about the evolution of AI as well. Due to time constraint, I can talk about the evolution of these large language models, how it
Mm-hmm.
got evolved. So
Mm-hmm.
basically, like it all started with sequence-based modeling, right? So we had got these RNNs, recurrent neural networks. So where like you will feed or you will ask the question based on the sequence, and your model is to generate the output. But first in NLP, like first like we started with RNNs, then we went into the LSTMs, right? So in LSTMs, like the problem with RNNs, like it was not capturing the context of the
Yeah.
longer strings or longer text.
Yeah.
Okay, so that was the problem with RNN, and later like researchers come up with LSTMs as well.
Yeah.
Like that long context thing, it handled to some extent, but yeah, still since it's a sequence based model, so training time used to be more, and accuracy was not up to the mark with LSTMs. So
Okay.
later, like GRU came, right? So it solved some of the problems. Like there was a gradient problem was there. I mean to say, uh, yeah. So there was some gradient related issues were there during training. So GRU used to solve that, and but yeah. like these RNN, Celestium, and GRE, if you take, so these are all sequence-based models. So later, like there was one revolutionary paper. So that paper is called "Attention is All You Need."
Yeah.
That's from the Google.
Yeah.
So where there the task was for the machine translation,
Yeah.
translation from one language to the other.
Yeah.
But that paper, right? So it gave way, or it gave things for currently what the LLMs we are using. So that paper was the base, and that paper, like there were a lot of things in that paper. For example, they introduced self attention,
Yeah.
and they introduced like casual attention,
Mm-hmm.
and they introduced like positional encoding. What's the importance of it? Right. So later, like once after this transformer paper came, that was an encoder decoder based model.
Yeah.
So after that, BERT came. So BERT basically it's the encoder. Like in transformer, I told you like we had got two modules. One is encoder and decoder. So
Mm.
BERT was constructed by taking the encoder from the transformer.
Yeah.
And BERT was trained on next sentence, sorry, next word prediction as well as the mass language modeling. So that was the training technique on BERT.
Yeah.
So later came the GPT-2. So that was also a really kind of evolution in NLP, natural language processing space, where like that was a decoder. They took decoder from the transformer, and yeah, so that was trained on next word prediction or next token prediction.
Mm-hmm.
So after that, like there were a um, lot of research happened in the how to train faster, right? So I told like with less memory, how you can train the bigger models,
Yeah.
right? So later, like they increase, like for example, they consider like 3 billion model came and 7 billion model came, and yeah, like that goes on. But in order to um, keep up to date, right? So you must refer to the research papers. So like what is the current trend happening in the AI domain? That too with for example, it can be in NLP or it can be in computer vision. So it is moving at very fast scale. So you must be referring to the research papers up to date, and uh,
Okay.
yeah, yeah. So that's how it goes.
Yeah. And like what kind of a skill set? So we are at the end of this podcast. So what kind of a skill set a person should hone to, become a part of a great AI team? Like any tools or courses that you would like to recommend?
Yeah, so like in Coursera, there are a lot of good courses. Like for example, if person want to start in NLP, so there
Okay.
is a course in Coursera called specialization in NLP. I don't specifically remember that name. Okay,
Mhm. Mhm.
but there is some course like NLP specialization.
Okay.
So that's from the I think deeplearning.ai.
Okay.
So that's really a very very good, like in understanding fundamentals of language models, and like those are all and up to the LLMs. Like that is a very good course I can recommend for who wanted to start in NLP space, and like for freshers who wanted to start in machine learning and deep learning, so they can go through the fundamentals of mathematics. And as far as I remember, there is one very good course in Coursera, I think, from the Imperial College London
Okay.
on the mathematics part. So they can refer that. I referred that course, and from Stanford also in EDX, right? So in EDX there is one course from Stanford, so that is
Mm-hmm.
also very good on mathematics. And if someone want to start on machine learning, so from Andrew Ng, like definitely Andrew Ng is the best in this field. So there is one course from Andrew Ng on fundamentals of machine learning, that is present in Coursera.
Mm-hmm.
And for deep learning part also, the course is from there is a course from Andrew Ng. So that is really a very good course, right? But for the freshers who want to start this machine learning and deep learning, so just make your fundamentals in mathematics strong, and later you can dive into the machine learning and deep learning and refer to these courses.
Okay. Yeah, so I think we are done with all the questions. So that's all for today, folks. Hope you love listening to Karthik and had great insights from this episode. Please leave your questions in the comments, and we will reach out to Karthik to answer those for you. Thanks for listening.
Yeah. Thanks, Akshat.